I can find the volume of another gas in the problem, okay? By looking at the mole ratio. That's all it does, okay? So, let's go on to mass relationships. This is where we really want to spend some time today. On page 52, and so we're going to look at example 6.6 together. This is going to look really complicated when you see it all together. Just remember, it is a skill, and it's going to take a little time to remember how to do it and to learn and to get the process down, but it's a process, and you just have to learn the steps of the process and you will get it. So I'm going to go ahead and write the formula here because we're going to use it so many times. I hope I can save room here and write it and still have everything we need to see. We're going to try our best. So there's my formula. So the difference in this problem is we are not going from moles to moles. It wants to know how many grams of Ga and HCl would be necessary if you needed to produce 100 grams of this. So basically we're saying 100.0 grams of GaCl3 is equal to how many grams of Ga and how many grams of HCl. Well, I don't have anything that makes me go grams to grams. So I can't do that. I can only go from grams to moles of something because I know how to do that for a single entity. And then I can compare moles to moles. So we use this little picture of you have your mass machine, like just like your weights, we don't use those little scale masses. You can never cross over and find grams to grams. So when we're getting a mass, we usually get in grams. You are never able to go straight there. It just doesn't work. You can't go from grams to grams. So what we want to remember is that if you have grams of something in the equation, you're looking for grams of the other, you always have to go under and do it a different way. You have to find the moles. So this is my little mole underground. And if I find the mole of the first thing, then I can find the mole of the second thing, then I can go back up and find the grams. So it's really a little bit longer of a process, okay? You can't go from grams to grams. You can go from grams to moles of one thing, and then you can relate that to moles of another, or you can find grams and relate it all the way back to grams of another. So it just depends on how we're going through with that. Okay, so here's what I'm going to do then. I first need to know moles because I'm thinking of taking that grams of the first thing and going down to the mole. So I'm going to take my GaCl3 and I need to figure out how many grams are in a mole so I can tell how many moles I have in 100 grams. So I look up the thing for barium. I have one of those and it is 69.7 AMUs. Okay, and chlorine, there are 3, and they are 35.5 each, which is 106.5. I add those together and I have 176.2 AMUs. Okay, well, that tells me that 162.2 grams is in 1 mole. Okay. So understand that I'm not saying GaCl3 weighs 176.2 grams. If I wanted to know that, I'd have to take my 176.2 AMUs and multiply it by the 1.66 times 10 to the negative 24 grams in an AMU. But I know that I'm trying to get moles, so I have to get the mole ratio here so I can convert my grams to moles, okay? So I come over here, then, and I take 100.0 grams of GaCl3, and I want to say then that there are oops, wrong direction. I want my G's to cancel. there are 176.2 grams of GaCl3 in 1 mole of GaCl3. So the grams cancel, and 100 divided by 176.2 is 0.5675. moles of GaCl3. So there's my first piece. Now, I come back to this little drawing and think about it. I have the moles of the first thing. I need to go find the moles of the things I'm going to be looking for. And so I'm comparing moles to moles, which comes from the equation. I'm going to go ahead and find out how many moles of Ga and how many moles of HCl this would be. Okay? So I'm going to erase this thing out of the way here because it's taking up a little too much space for me to show you all this. Okay? So I know that I have 0.5675 moles of GaCl3, and I want to go to my equation and see how that compares with just the garium. Well, there's 2 moles of GaCl3 for every 2 moles of garium. So essentially it's like I'm taking that times 1. So 0.5675 moles of garium is what I have used. And this part we've already done before. We've gone from moles of one thing to moles of another. Okay? We just added an additional step at the beginning, and we're going to have to add an additional step at the end in just a minute. Okay? So that gets me that far. And I'm going to make some space here for this bottom piece. All right. So I'm having to re-record for you ladies because, I don't know, it wasn't quite working right in class, and there was a glare, and it just was not going to be what we needed it to be. So, so the next thing I want to do is find the moles of HCl. So I start with my 0.5675 moles of GaCl3 again. And I know the moles of HCl, there's 6 of those, 6 moles of HCl for every 2 of the GaCl3. You can see why it's really important now to write what we're looking for. Moles of GaCl3, moles of Ga, because we've got moles of everything happening over here. And it gets kind of busy. When we multiply that out, this times 6 divided by 2, we get 1.703 moles of HCl. So there we go. So now I know how many moles of each thing I used. Okay? Now, I still have to take those moles and convert them to grams. So I'm going to have to come over here to the side, and I want to find out garium, because I know how many moles I have, but I want to find out what that is in grams. Well, garium is 69.7. So garium would be 1 times 69.7. That's 69.7 AMUs. That tells me that 1 mole is 69.7 grams, okay? So now I can convert this number. I can say 0.5675 moles of Ga times 1 mole on bottom, 69.7 grams on top, equals, and I multiply that out and I get 39.6 grams of Ga. I'm sorry, that's running into the other writing, but 39.6 grams of Ga. Okay, then I'm going to do the same thing for the HCl. So let me just get that out of the way. Now notice I started with 1.703 moles of HCl, so that's what I'm going to be converting, but let me come over here and write this. I'll try to make better room next time so you can see how I would put it all together on my page. Okay, so for HCl, you have one hydrogen, which is 1.01 AMUs, and you have one chlorine, which is 35.5. This ends up being 36.51. On the test, some of you didn't have your precision right on this. The precision is to the tens place, so we're going to ignore the 1 and just say that there's 36.5 AMUs, and that means that there are 36.5 grams in a mole, okay? But we're starting with that 1.703 moles down there in the corner of HCl, and we're going to be converting that. So we're going to be converting that to grams. So 1.703 moles of HCl times 1 mole of HCl is 36.5 grams of HCl. So we take those and we multiply them, and we would get 62.2 grams of HCl. Okay, so that's what it's like when you're finding all of them. I'll kind of show you what my page looks like just so you can see how I do it all on the page. I just try to keep it really organized. And I always, these are my questions up in the corner. I do my mass per mole over here to the side because I know that I'm going to need to find each of those eventually or as I go. So I just put all those mass per mole over here. And then over here you see my work of first finding out how many moles of the thing that I was given in grams, then convert that to the moles of the other, to the moles of the other, and then I come down and convert the moles back to grams so that you can see the process of what we were talking about in that little drawing. The mass is at the top. You got to come down and find the moles of it, then compare that to the moles of the other things. So all this is finding the moles of the original, comparing that to find the moles of the things I'm looking for. Then I can take the moles of the things I'm looking for and find their grams. So that's kind of the whole process as you go. So if you want to find a mass relationship between one chemical and another, then you're going to have to convert to moles. You just have to do that. Okay? And it is a process. It's going to take a little time to figure that out. It's a skill, so you just keep working until you get it, okay? So let's take a look at 6.7. So for example 6.7, it says the human body produces energy and it requires to live by burning the simple sugars like C6H12O6. So it's burning the C6H12O6 and it creates carbon dioxide and water. And so it goes on to tell us basically that the carbon dioxide that is produced is really exhaled when we exhale. We exhale carbon dioxide. The water is eliminated in our urine. So the question then was, if the average adult burns 1.2 kilograms of simple sugars, so 1.2 kilograms of that, I'm gonna write my question over to the left so I can keep my organization here. 1.2 kilograms of C6H12O6 equals, the question is, how many grams of water is eliminated? So we're wanting to go from kilograms of C6H12O6 to grams of H2O. Okay? Now, one thing I'm noticing here is I really need to convert that kilograms to grams because that's usually what we're working. So let's go ahead and make this 1,200 grams, okay, of C6H12O6. So there's that. Okay? So the first thing I'm going to do is take the number of grams and convert it to moles. Okay? So 1,200 grams of C6H12O6, I have to convert that to moles. Well, how do I know how many grams are in a mole? Hey, I have to come over here and find out the mass per mole over here. Of C6H12O6. So in order to do that, I'm going to have the carbon and I'm going to have 6 of them. And I'm going to take that times each carbon is 12.0. Then I have H's and there are 12 of those times 1.01. And I have oxygen and there are 6 of those times 16.0. And we get these numbers from the chart, right? So I seem to be rushing through that. But you would have to take a second to look it up in the chart, okay? And I think all of you do a really good job with that. You guys understood that part. So I add all those up, and I have 180.12. Precision says I need to go to the tenths. That 2 is not going to bump anything up or change it, so I'm just going to ignore it and understand that there's 180.1 grams in a mole for my C6H12O6. So I can come over here then and write that 180.1 on bottom in 1 mole, okay, of C6H12O6. So when I multiply that out over here, I'm going to get 6.7 moles of C6H12O6. I'm going to keep these organized because I'm also going to be looking for your answers that way. So please make that a little simpler for me, looking for your answers that I can see it over there. So thinking of my little picture, I went from the grams down to the moles of the first thing. Now I got to convert over to the moles of the second thing. You see, so I'm visually thinking of this whenever I'm doing. And I only need to find the moles of one thing. So I say 6.7 moles of C6H12O6, and I get my mole ratio from here. I'm looking for water. It's 6 moles of water for every 1 mole of the sugar. So 6.7 times 6. And we need 2 sig figs when this happens because we started out with 2 sig figs in our 1200. We ended with 2 sig figs here. And so you end up getting 40 when it rounds. And I can't leave it as 40 because then I would only have 1 sig fig. So I need to write this as 4.0. I need 2 sig figs. So I'm going to write it as 4.0 times 10 to the first. That would give me these 2 sig figs here. Okay, so there's that. Okay, so the next step is to now take my moles of water. I'm underground moles, and I'm going to go back up to find the grams because it's this mass of grams goes down into the mole with the little nose and eyes over to the mole, and then I can go back up to grams. So I went from grams to moles there, then from mole to moles here, and now I'm going to go from moles to gram in my next step. So I'm going to start out with the 4.0 times 10 to the 1 moles of H2O times, and I have to come over here and do my H2O, right? Which is hydrogen. There are 2 times 1.01. Oxygen, there's 1 times 16.0. And that's 18.02. Again, we're wanting precision to the tens place, so we'll just use 18.0. So there are 18.0 grams in 1 mole of water. So that's going to help me over here, that there are 18.0 grams of water in 1 mole of water. The moles cancel. And 40 times 18 leaves you with 720 grams of water. And that's the end of example, the first part of example 6-7. So we're going to look at the second part of example 6-7. Okay. All right. In 6-7, the second half, it's talking about these toxic acid spills. And they can be cleaned up sometimes by, if it's an acid, it can be cleaned up by some kind of base. So our base here is barium hydroxide. And this is a liquid and a solid. And barium chloride is aqueous, and 2 waters, which are liquid. Okay, so there's my full chemical equation. The question over here, though, is if you had spilled 540.0 grams of HCl, how many grams of the barium hydroxide would you need to neutralize that acid? Okay. So I can't just go from grams to grams, right? I have to go from grams. I need to take this one from grams into its moles. So over here, I'm going to do this mass per mole over here. Hydrogen, 1 times 1.01. Chlorine, 1 times 35.5. So 36.51. This 1 is not going to affect the 5, and we only want it to the precision of the tens place. There are 36.45 grams of HCl in 1 mole of HCl, and that's nice because that's where we're going to start. So we're going to change this grams into moles. And there are 36.5 grams of HCl in 1 mole of HCl. So the grams need to go on bottom to cancel. So 540 divided by 36.5, you're going to get 14.8 moles of HCl. Okay, so we've now gone from grams down to moles of the first thing. Now we can take the moles of the first thing and go over to the mole of the second thing. If we were thinking of that, we do that by looking at the mole ratio in our problem. So we want moles of BaOH2, so that's going to be on top. And we're going to use the moles of HCl on bottom so that it crosses out. So how do those compare? There's 1 mole of the BaOH2 for every 2 moles of the HCl. Okay, so we're going to multiply that through, and we would get 7.4 when we do that on the calculator, but we need 3 sig figs, so we're going to say 7.40. 7.40 moles of BaOH2. So we went from grams to moles of the first thing, then we compared and went from moles of the first thing to moles of the second. Now we're going to take the moles of the second and turn it into grams. And the way that I do that is I have to come over here and do this, find out how many grams are in a mole. And this one's a little different than something that we've done before, because we haven't really done these parentheses before. So I want you to understand that we have 1 barium here, and I can go look up barium, and barium is 137.3. Okay. Then my oxygen, there are actually 2 here because these OH are kind of stuck together and it says we have 2 of them. So that's going to mean that we have 2 oxygens and 2 hydrogens. Okay? So just pay attention when those parentheses are there. The number outside applies to both of them. Okay? So you're going to double whatever you have inside. So oxygen is 16.0, hydrogen is 1.01. So we will have a 32.0 over here and a 2.02. When I add all those together, I get 171.32 AMUs, but again, we want precision to the tenths. 2 is not going to round anything, so we're going to stick with that. 171.3 grams in 1 mole of BaOH2. Oh, and I need to show you that. Sorry, lost that. Okay, so now I'm going to take these moles, okay, of BaOH2, and I am going to multiply it by 1 mole of BaOH2 on bottom is equal to 171.3 grams of BaOH2. So 7.40 times 171.3, the moles cancel. I want 3 sig figs, so my answer is going to be 1,270 grams of barium hydroxide. And that's the end of example 6-7.